Okay, so it's been about a week since we made our fresh batch of kombucha. Now, now that it's done, the fermentation has been going and a lot of acetic acid has been produced. We've got here 3 bottles of kombucha. I put them into these bottles for what is known as the second fermentation. What happens is I place them in these airtight sealed bottles and leave them for about 2 to 3 days. This one, I added apple and cinnamon to it, because the point of second fermentation is to add some flavor and to add fizziness to your kombucha. By adding extra sugar to it, the fermentation process can still continue, because in this kombucha there is still some SCOBY, and it's still fermenting that sugar. But by keeping it in an airtight seal, the carbon dioxide that is produced stays there and it's forced to dissolve back into the solution as it becomes pressurized inside, making it fizzy. Now there's a lot of pressure buildup, so I gotta be cautious in opening this. Okay. Awesome. And you can see there's some fizz, which is great. That's what we want. Oh yeah, and I know it says lemonade, but I swear to you, this is kombucha. Cool. Now that's all cool and all, and it tastes really great, I'm sure, but I already opened this one earlier, so it's fine. There's something I've always been wanting to try. So, because there's a lot of acetic acid in these drinks, it's very acidic. Now, we all know that we can use indicators, color changers, to tell how acidic or how basic a solution is. So I looked up different ways to try to change the color of my kombucha based on its acidity, and I found one. Right here is a sample of butterfly pea tea. It's a tea made from butterfly pea flowers. Butterfly pea flowers are blue, and as you can see, it's a very blue solution. And it's blue when it's neutral. When it's in a basic solution, it turns purple, and when it's in an acidic solution, it turns from a yellow to a pink. And I thought that would look super cool in kombucha, though I'm not sure if it's going to work. This is my first time trying it out, so we're going to see how it goes. The reason it's a indicator is because the petals contain acetylated delphinium, or delphinidine, that's it, yes. And that acts as a great indicator. So right here I've got lemon juice, which I know is acidic. So I'm going to see how it color changes by adding a little bit to it. Oh, and you can see it turns to a pink. Oh yeah, that's great. Now it looks like pink lemonade. You know, that's it. Pink lemonade is just lemonade with with butterfly pea indicator. Right here I got ginger beer. I'm pretty sure it's acidic. I don't know what it's going to look like with the brown golden color, but let's see. Okay, it sort of turned to a darker purple, and then pink. Looks pretty good. Now I'm going to save the rest for my kombucha. I want to see what happens next. Okay. Turns to like the pink mixes with the gold and turns to kind of just a dark purple. Adding more of it makes it almost red. Or just really dark. Okay, well that doesn't look nearly as pretty as I would have liked it, but still. Oh, actually, from the top, it looks very red if you want to look at it. Ooh, that's actually kind of cool. All right. Anyway, yeah, that pretty much sums it up. Yeah, so thank you so much for watching me make kombucha and talk about the science behind it.